Hello everyone, hope you're doing well. Just to recap last video, we quickly went over how to merge two or more different data sets together by a common ID number. And in this video, we're going to be covering how to make a table that you might see in a poster presentation or a research project that um, lists variables of interest and then the measurements and values that you want to present. And uh, it will be through using a function called table summary, um, which comes from a different package outside of the tidyverse called GT summary. So the first thing we're going to do is move our data. So, we're going through this hypothetical that we have this data that we have to work on in R. So we're going to move our data into our working directory. So I already have this folder with the data of interest. I'm going to move it into my working directory. Now it's in my working directory, I can access it in R. So I'm going to make another R script file just to keep everything organized and separate. And I'll call it just like summarize data. So the first thing we always do is we load in the uh, functions that we're going to be using. So we're always using tidyverse. And then the next one we're going to be doing is GT summary. And you're gonna have to download this. So you're gonna go through the steps of doing install packages, and then um, and then once you have it installed, with GT summary, you can just call it up using the library function. So we'll run these, save it, and then we'll read in the data that we have that we want to create a table for. So we're gonna always make our comments. And then we're actually going to make a table. So we're going to um, read in this data, and we'll just call it BM raw because it's before we've done anything to it. So we're going to be, since it's a CSV file, we're using read underscore CSV, and we have to do the path, the file path from the working directory. So we're in data to summarize slash body measures dot CSV. Now that we have that, we have um, this big data table that has a lot of biometric data and demographic data about these patients or individuals in part of the study. Um, so and a lot of them are numeric, so we're going to be able um, to find means, medians, or whatever type of information we're trying to look at. So once we have that data in, now we can start to actually work on the data. So just so we could refresh the lessons we learned from the other videos with how to use the functions in the dplyr package, we're going to create some variables out of the variables we have here. So So let's make some um, categorical variables based on uh, the um, the continuous variables that we have here. For instance, how about let's make a BMI. Uh, let's make a BMI and then obesity measurement. So we have height and weight, but we don't have BMI. So uh, the measurement of BMI is equal to weight. Found the equation for um, BMI in kilograms and meters squared. That's why I was confused about these weights and heights. But the height is in centimeters, and the weight here is in kilograms. So in order to create a variable that is a measurement for BMI, we're going to have to use the mutate function. So now let's make a new data object called BMI, body measurements BMI, because that's what we're making. And we're going to make it from the raw data set. Then we're going to take the raw data set and pipe it through into the mutate function. And we're going to make a new variable called BMI, which is going to be equal to, and I'm just going to include this round function because I don't want it to, have so many decimals. So so what we're going to round is the weight variable, and divide it by the height variable divided by 100 because it needs to be in meters squared, not centimeters squared. We'll close that, and then we're going to square it. So we do that by doing this up triangle and 2 to square it. And then, so that's the number that is going to get rounded, is the product or the answer to this mathematical equation. And we're going to round it to the 10th place. That's basically saying, like, this one is just saying how many numbers to the right of the decimal point do you want to keep. So now that we have that, we're going to then, so that's just going to make the BMI. But I want a variable that says whether the patient is obese or not. So the way to do that is we're going to do mutate again. We're going to be making so that's going to be a binary, 2 variables. I'm going to make overweight, and then I'm going to make obese. So overweight, we'll do overweight. We're going to say, so you start with a new function, and you're going to, what we do next is instead of using a function we used previously called case when, which was a function we used to make a continuous variable into multi-leveled categorical. If we just are going to be using 2 levels of a variable, such as like a binary variable, then we could use the function if else, and then we do if else, which takes in a logic test. So if the BMI is greater than or equal to 25, we're going to, if it's greater than or equal to 25, then it's the value is going to be 1 for this variable. But if it's less than 25, then it'll be 0. So this is like the first number you put in is what the value will be if this test is satisfied, and if it fails, then it will get a 0 as a value. So now we're going to make that variable, and then we're going to make an obese variable, which is going to be the same one, except the threshold is going to be higher. It'll be if BMI is greater than or equal to 30. And then we'll do 1, 0 again. And then we'll make, let's say, one last categorical variable where if we'll call it age cat, it's going to be a categorical variable based on your age. Let's say if it's greater than 30, we'll say over 30. And if it's less than 30, we'll just say 30 or under for the age. And it'll be a character variable. So age is greater than 30 over 30. And so if not, else it will be 30 or under. Okay. Now we can run this. And now we have 4 more variables. We go all the way to the right. You see now we have this BMI variable, which is the weight divided by the height divided by 100 squared. And we have overweight. If it's over than 25, we'll get a 1. And then we have obese, which is over 30, and then I'll get a 1. So if it's above 30, and it's above, so if it's above 30 or above, then it's going to get obese and overweight as a 1 value. So now that we have those, we can actually get into the table summary function. So let's say we just wanted to see, we wanted to get a description of the obese variable, overweight variable, age cat, the one we made, gender, shoulder girth, wrist diameter, and ankle girth. So what we're going to do is we're going to use the new data set, and we're going to type it into a select function, which will allows us to only look at the variables or columns that we care about in this table. So we don't have to print the table with every single column in it, only the ones that are relevant. You never want to make a line of data too long because it's a little harder to read. So when you can, just press enter to go to the next line. Okay, so now we've selected the ones we care about. So now we can use the table summary function. And right now, I just want to do, if you just typed it into the table summary, what would happen? So now it's, since table summary is like the last thing that's getting typed into, it's going to just execute that code. It's not going to save it into an object. But you can see here in the viewer panel that it made a table, and currently it shows for the binary data, it shows the distribution of or the count and the percentage of the patients or observations that are obese or are overweight. So you have 19 observations that are obese, so it's 3.7%. So 19 divided by 5.7, 500, and then did the same thing for overweight. For age cat, it's the same thing. So you are either older than 30 or above, or 30 or younger. So you're ever over 30 or you're 30 and younger. So this should add up to 507. It gives you a distribution, percentage of each. Then for gender, it does the same. And now for the default for continuous variables is that it gives you the median, which is like the when you set up all the numbers, number in the middle, or the average of the two closest numbers to the middle. And then it also gives you the IQR, which is I believe it's the 25th percentile of your data and the 75th percentile, which just means like the number at which 25% is at or below that number, and then the number at which 75% is at or below that number. So that's if you don't do anything. And you can see here, like if you just pipe these variables into the table summary function. However, we have control over how these names get presented, as well as the type of data that gets presented in this column. So now, so I just want to go over some of these things that we can add to this code to make it a little more tailored to what we're looking for. So I'm just gonna add another line. So I'm gonna fill some stuff out into the table summary. So this means I added in this argument that statistic equals all continuous, and for all continuous, basically it's saying the answer you want to give should be the mean function. So everything in this parentheses is going to be presented in the column over here. So it's saying for all continuous, which are these variables, you're going to have the mean, and then in parentheses, you're going to have the standard deviation, and that's going to be instead of the median. Now it's the code just running. So now you see here in the bottom that it changed the data, or the statistic that's going to be shown. And you can see here that this is the mean, and then here is the standard deviation. But these values did not change because we only changed the continuous variables. Now, now we can also change what it does for the categorical, and I'll just copy and paste this. Sorry, I realized I didn't properly label. So, okay, so now we're also going to impact what happens to the categorical variable. So for all categorical variables, we are going to present the percentage of only the percentage that it makes of the total, and not the count. Let me just make sure I have all this right. Oh. All right, that should be good. I'm missing. All right, I realize I'm missing a. Oh, I see what I did. So you can't just like add another argument to this. Like if you're only changing one thing, like all continuous, all categorical, you just read that out. But if you're doing multiple, you actually have to put them in a list, which is pretty easy. You just add the list function or argument, put it in parentheses, then you add another. Now we're good. Okay. So yeah, now you can see um, we just put the percentage, which was represented as P, and then a percentage sign in the box, and that's it. Um, so now let's say you wanted to change the uh, names for this. Like you want to put this in a in a poster, and you wanted to clean the names up a little because like underscore doesn't look so nice. You want to make it more presentable. So what we're gonna do is add another argument. So we had statistic that influences the statistical aspect of this table, which is this part. And now we can also change the name, um, which um, oops, this should be on the inside. Okay, so now we'll do label. That's how we change the this column here. So label, and then we're just gonna list. We're gonna make a list because we're working on multiple uh, variables here. So we're gonna list out all the variables, and then um, so let's start with obese. So let's say we want it to be uppercase. So we'll do obese. So that's the original one, and then we're gonna change, and then we're gonna say what we want it to be. So we'll do in quotation marks obese, and then we'll do comma, and we'll do the next one. So we'll do overweight, weight. We'll make it overweight slash obese because we include people who are obese. Um, and then I'll just copy paste everything else that I had. But it follows the same format. So now if I run this, then you can see the names are a lot cleaner and more presentable. However, let's say we wanted to um, see how the certain measurements that we have, like obesity, rates of obesity, and these categorical variables differ across a categorical variable such as age, how like these measurements differ against age groups. So the way we do that is pretty easy. We just add in table summary. We started off by adding by, which is going to be the variable, and then the variable that we're going to be splitting it off by. So let's do age cat. And then we'll do that, just add a comma, and now when we make this table, and um, you would really want to do that if you have like an exposure, like with this procedure, with this medication, without this procedure, without this medication, and then they'll allow you to compare these measurements. Let's say these are outcomes that you care about. So it very nicely splits it up, and it says how many are in each, and it tells you the percentage and values. This time it's the mean of each. Um, and we can add a uh, overall, uh, and because we had this split up, it might be useful to see how like the entire study is how the entire study looks. So we can just um, add a pipe and do add overall, and I'll just add like another column. Hmm. That's not that it's not the most important, so I don't want to delay this video too much or make this so much longer. But there is another thing I wanted to add um, that allows us to test the statistical significance for to see if like these measurements here differ from one another significantly from the groups, which is important when you want to know if the differences you see in a treatment group are because of statistical variation or because of an actual difference in outcomes. So what we're going to do is we'll add a um, we'll add the statement add p, and then that's going to give us p values, and then the test will be equal to all continuous, and then do a t-test. And the student t-test is a way to compare the mean values amongst the different groups. And so the test is just saying like what the actual, when you're doing this function, you're saying this is the test, like this is the test we're going to use for all of the continuous, and it's going to be a t-test. Awesome. So for um, so you can see for here that they did a t-test to compare the average number, like average measurement for shoulder girth, wrist diameter, ankle girth, um, and they gave you the p-value to tell you if it's significant or not. And this is pretty, it's pretty useful. Like it kind of adds, it puts all of your results into one nice table. And what's also nice is that if you wanted to, like get this off of um, all our studios and actually put it into like a document you're working on, you can just click the export and save it, to your desktop, and it'll save like a nice image of this. I believe for the p-values here, yeah, you could say they use the chi-square test, which is what you'd use for count data, and or for binary data. And you can see that there's significant difference in both if you're using a value of 0.05, alpha of 0.05, that there's a difference in obesity and overweight between people who are over 30 and under 30. So that is going to be it for this. I'm going to definitely going to share the code for each step that says what each line does, because I know this whole thing together is a lot of code, but it'll give you like a stepwise, um, it'll give you a stepwise process of what each code does, and um, it should be a little more easy to follow than just looking at this. This is we kept on adding and adding things. So thank you so much for watching this, and I'll catch you in the next one.